Right, so last question of IAL Pure 2 paper. It's October. I think so it's October 2023. Last question and quite complicated one, right? So let's get started. Alright, find in the ascending powers of x the second, third, fifth term of binomial expansion of 3 plus 2 x squared, 3 plus 2x whole bracket to the power of 6. All right, now what I'm going to do here is just apply the binomial expansion. So this is going to be 3 to the power of 6 plus 6 1. All right, because it's needs for second and the third, so I start with first term, second term, and third term. All right, and this is going to be 3x6 minus 1, and this is 2x to the power of 1 whole. All right, now we have 6 to the power of 2. Now we have 6 minus 2, and we have times by I'm going to write it here, 2x to the power of 2 as a continuation, all right, of this one. And okay, now we don't need the third, fourth, fifth. Now it is going to be fifth term, so I'm going to use one formula, okay, which is going to be nr, right? Let me nr is going to be a n minus r br, this formula, to find the any term of the binomial expansion. Now it is asking for the fifth term, so that means the r is going to be 5. No, it's not going to be 5, because now you notice here when we find the second term of the expansion, we notice that the r was one less of it, so that means the r is going to be 4, right? So now n is going to be 6 4, right? And now we have a, which is just 3 6 minus 4, and br, which is going to be 2x to the power of 4. All right, now let's do the expansion. We don't need the first term. All right, so now let's find these terms. I'm going to put this into calculator. Make sure you put as 6c1, the NCR button. Right, so putting this into calculator, we have these answer of 21916x plus 4860x squared and 2160x to the power 4. All right, now what I'm going to do over here, now they're asking for part B. For a particular value of x, these three terms form a consecutive terms in a geometric series. Find the value of x. So whenever they say consecutive, so basically now over here, this 916x 4860x squared and 2160x to the power of 4, this is going to be the first term. All right, this is going to be second term, and this is going to be third term of a geometric sequence. All right, now they are asking for particular value of x, so this value of x they are basically saying. All right, now we have to find this value of x. So whenever they ask about a geometric series, you should know that whenever we divide this by this, right, to get common ratio, so we divide u2 by u1 to get common ratio, and we divide u3 by u2 to give common ratio, because it's same and it's consecutive. All right, so there is like common ratio multiplied every time, which is going to be same because it is consecutive. So I'm going to do here is going to divide 4860 over 2916. This is going to be x squared. X is equal to 2160x to the power 4 is equal to 4860x squared. All right, now we can simplify these fractions over here. So 4860 over 2916 is going to give us 5 over 3. Now this can be subtracted, so we have x goes out and we have x to the power of 1, so this is just x. All right, 5x over 3. Now you can simplify this fraction over here as well, which is going to give us 4 over 9. This power can be cancelled out, and this we are going to left with 2. All right, now easiest thing to do here is to bit of cross multiplication over here. So to find the value of x, this is the best way we can do. So 9 times 5 is going to give us 45x, and 3 times 4 is just going to give us 12x squared. This is a quadratic equation. Take this to other side, it's a quadratic. All right, so we can factorize x over here. So we have 12x minus 45, set them equals to 0, and x is 0, and we have 12x minus 45 is equal to 0. And take 45 to other side, and you divide by 12, we have x. So 45 divided by 12 is going to give us x is 15 over 4. All right, and that's our final answer. 0 cannot be final answer, because if you put back to the value of x, the whole geometric series is going to be 0, so that's not a realistic one. All right, there. All right, now part A and part B are done. Now we have to go to part II, which has no relation with part 10A, so I'm going to erase off to form a bit of space. Right, okay, now in a different geometric series, all right, the first term, okay, is sine squared theta. All right, and the common ratio is 2 cos theta. Sum to infinity is 8 or 5. Show that 5 cos squared theta minus 16 cos theta plus 3 is equal to 0. All right, so now first thing is first, so we need to write down what we know. The first term is sine squared theta. The common ratio is going to be 2 cos theta. The sum to infinity is going to be 8 over 5, and we need to show this. So now basically, if they are telling sum of infinity, basically we have to use this formula over here, the sum to infinity formula, which is a minus 1 over r, where a is the first term and r is a common ratio. All right, now a is sine squared theta 1 minus r, which is 2 cos theta, is equal to 8 over 5. Do cross multiplication over here, the best thing you can do. All right, take this to this side, multiply here. So 5 sine squared theta is equal to 8 times by 1 minus 2 cos theta. Now expand the bracket, so we have 5 sine squared theta is equal to 8, and this is going to be minus 16 cos theta. Now probably you should notice something, that they have eliminated signs from this equation, so that means that we have to, this thing can be rewritten as sine squared theta, a trigonometric identity, is going to be 1 minus cos squared theta. We're going to replace that with this, so 5 minus 1 cos squared theta is equal to 8 minus 16 cos theta. Now expand this bracket, so we have 5 minus 5 cos squared theta is equal to 18 minus 16 cos theta. Now over here, now we can do is minus 5 on both sides, add 5 cos squared theta on both sides, and what we are going to end up with, so this cancels out, so we have 8 minus 5 is just plus 3, and we have 5 cos squared theta minus 16 cos theta plus 3, and we have proved it, we have shown it. Hence find the value of the second term in the series. All right, now let me just label this as part A and this is part B. Now for part B, first thing is first, we are going to solve this trig equation. Now in order to solve the trig equation, we are going to let cos theta is equal to y. It's a hidden quadratic, so this means that we have 5y squared minus 16y plus 3. Solve it. All right, 0 is going to be y minus 3 and 5y minus 1. So y is just 3, all right, and y is equal to 105. Now let's just, now since cos theta is going to be cos theta is equal to 3. Now this is invalid because if you try to draw a graph for cos, all right, let's say we have a graph. This is not a valid solution, I will tell you why. Let's say we draw a graph and we have 1 and minus 1, 90, 180, 270 and 360, and we draw a graph something look like this, and we need to find solution at 3. Since y is 3, we need to find the value of theta. So you see that there are no solutions. We draw a straight line at 3, there are no solutions. So yeah, so that's why we are not going to, we cannot solve this. Yeah, now we can take 1/5 because it falls within the range. All right, so cos theta is equal to 1/5. Now here things get a bit tricky. Some people would take inverse of sine, and you don't need to do that. Let's just keep it as it is. All right, you know why. All right, now you have to find the second term in the geometric series, and now you should notice that okay, so let me just, second term of the series. All right, so in order to find the second term of the series, we have sine squared theta. All right, it's the first term. Now we have to find the second term over here, second term. And how we can find the second term? We have to multiply by the common ratio. And what's the common ratio? Well, the common ratio is going to be 2 cos theta. But since it is says the exact value, let me highlight that, exact value. All right, exact value means that if we take the cos inverse of this, we are going to get something like decimals. All right, but we don't want that. You don't want that, and that makes things a bit trickier over here. But what we know so far, that we can replace, okay, let me take it, this cos theta, all right, with this. All right, got it? Yeah, because it wants the exact value, so we are going to replace 1/5 with cos theta. All right, now how about sine squared theta? It's the first term of the sequence. So what we are going to do to replace sine squared theta, you should know the trigonometric identity, which is 1 minus cos squared theta. And also one identity you should know, that this cos squared theta is same as cos squared theta whole squared. That's very, very, very important. All right, so that means that we can replace the sine squared theta, replace it with 1 minus cos whole squared. All right, cos theta whole squared, because cos squared theta is same as cos theta whole squared. and we know that we can replace this cos theta with 1 over 5. Got it? All right, you should get it. Now, in order to find the second term of the series, what we are going to do is, let me take a different color. Let's just take blue, right? All right, so now we have 1 minus cos theta whole squared. Now cos theta we know is 1 over 5, square it. All right, and this, the first term, all right, this is the first, times by the common ratio. Now the common ratio is cos theta, which is 1 over 5, and now from then we can find the second term of the geometric series. All right, now just put this into your calculator. Let's see what. Right, so if you put this into your calculator, we have 48 over 125. It says exact value, so it is better to keep as fraction. All right, hope you understood this question. Quite a nasty one, I know, but it all comes to the understanding, and you have to just apply your knowledge over here. All right, peace out.